In this presentation, we will learn how to delete the last node of the circular singly linked list. So let's get started. Let us suppose we already have this circular singly linked list and tail pointer is pointing to the last node of this list. Our target is to delete this particular node, that is the last node of this list, right? For this purpose, I'll keep a temp pointer which must point to the first node of this list, and then after that I'll use this procedure, that is this while loop, for moving this temp pointer towards right, because this temp pointer must point to the second last node of this list so that I can update the next part of this node and then I can delete this node. Okay, that is why this piece of code is required. While temp next not equal to tail, temp equal to temp next. Here we are checking this condition. If temp next is not equal to tail, then only I can get inside and I will move my temp pointer. Here, when temp next becomes tail, then we should stop. That is why temp pointer will stop at this point, right? After this, the temp next must be updated by tail next. That is, the next part of this node must be updated by tail next, that is this address 1000. This replacement is important because here, after deleting this node, that is the second last node of this list, must become the last node of this list, right? That is why it must be updated by the address 1000. After this, we can free our node, that is we can delete this node using free function. And finally, we must update our tail pointer so that it can point to this node. For this purpose, I'll keep this line of code. And this is very simple. The time complexity of all these operations will be big O of n because it depends on the length of the list. And here you know that traversal is involved, right? That is why order of n is the time complexity. Now let me just show the complete code in code blocks. Now you can see over here, this is the complete code. Here we have struct node, then we have add to empty function, add at end function, just like the previous lecture. Then of course we have create list function and we have del last function. This is similar to what we have seen already. Here first we are checking this condition. If tail is equal to null, then we should return tail. Then temp pointer is declared. After this, if tail next is equal to tail, that means if there is just one node in the list, then we should free that node. Then we will put null inside tail and finally we will return tail back to the main function. Otherwise we'll perform this procedure. This is also required, okay? Because here we just have to free our node and then we have to return the tail, and that is we are returning null, okay? After this, print function is similar to what we have seen in the previous lecture. And in the main function, tail pointer is declared, and after this create list function is called, then printf function is called in order to print this message list before deletion, then print function is called in order to print the list, and del last function is called after that, which will delete the last node of the list, and after this printf function is called in order to print this message list after deletion, and finally print function is called again in order to print the list after deletion. Now let me just execute this code. It is asking us to enter the number of nodes of the linked list. Let us suppose I enter 3. Let's say the first element is 89, then 76, then 44. So list before deletion is 89, 76 and 44, and list after deletion is 89 and 76. That means last node is deleted, right? Now let me just execute this code once again. This time let's say I enter 1. So let's say this is 90. You can see that list before deletion is 90, but list after deletion is no node in the list. So this is working fine, right? If there is just one node in the list. Let's say this time I enter 0. You can see list before deletion is no node in the list. List after deletion is no node in the list. So our code is working fine. Okay friends, this is it for now. Thank you for watching this presentation.